All right, so what we're going to do is introduce the idea of a new way to solve quadratic equations. So this is lesson 9-4, and we're going to solve quadratic equations by completing the square. So again, we're at 5, 6. Okay. So basically, completing the square it's a process that turns a binomial into binomial. Nope, I didn't think I binomial. Nope, I didn't spell that one right, did I? Binomial into a perfect square trinomial. Notice that in our title we talk about equations. So this does not work on an expression. This only works on a equation. So here's what I'm going to do. I'm going to give you a brief reminder of what we did in Chapter 8. So remember we had this, and we multiplied that out, and we talked about a pattern that developed. That when we're multiplying a binomial by itself, we get the same middle term twice. I'm going to get 5x, and I'm going to get a 5x. So what we had talked about a pattern is that I take my first number and I square it, and then whatever the sign is of the binomial is the sign I write in the middle. I'm going to double the product of the two middle terms, and then I'm going to square the last term. So that was a pattern we kind of saw. Now, some of you got that and said, okay, I embrace that. Some of you said, I'm not sure I feel comfortable with that. So you guys just multiplied out. Okay? What you need to notice is this. If I take this middle term and I cut it in half, so I'm going backwards now, because remember I doubled, and now I'm going backwards. And then I square it. So what's 10 divided by 2? 5. What's 5 squared? And that will always be the case. So what I'm going to teach you is using this notion of taking your linear coefficient, cutting it in half, and squaring it will create a trinomial, perfect square trinomial. Okay? So let's do an example of a problem from start to finish, and you'll see what I'm talking about. So we have something that looks like this. X squared minus 6x plus 12 equals 19. Now remember what I said is we want to take a binomial and turn it into a perfect square trinomial. So right now we have a little bit of a hitch. 12 isn't making that a perfect square trinomial, so he's in the way. So what we're going to do is get rid of him. And by getting rid of him, I mean take him to the other side by doing inverse operations. So I'm going to subtract 12 from both sides. So now I'm left with this binomial, x squared minus 6x equals 19 take away 12 is 7. Okay? So now what I want to do is to create a perfect square trinomial. And I'm going to use that pattern I just talked about. I'm going to take the number. Don't worry about the sign. I'm going to cut it in half. And the reason why I don't worry about the sign, what do I get when I square something? What kind of sign do I always get? Always get a positive. I'm going to square it. So what's 6 divided by 2? 3. And what's 3 squared? So what I'm going to do is I'm going to put it here. But here's the problem. This is an equation. Right now, I've unbalanced the equation because I did something to one side, but I didn't do it to the other side of the equals. So it needs to go in both places. Okay? So now I've created a perfect square trinomial. And I know it's a perfect square trinomial because I made it that way. Do you guys remember what we said the pattern was to factor a perfect square trinomial? If you don't play the game? I mean, you can play the game. Morgan says she remembers. What do we do, Morgan?
You take the first term.
Uh-huh.
Find the square root of it,
Okay.
and then you add the square root of the last term.
Be careful with that thought. I do need to figure out the square root of the last term. But the sign of the middle dictates what the sign of mine will be. Okay, now, if you still are foggy on that process, then you just factor playing the game. And what you'll notice is you get the same factor twice. Okay? And so you have x minus 3 times x minus 3, which is x minus 3 squared. On the other side, we have 16. So this is something that I saw some of you try on the test and you didn't know quite what to do. When I have a squared term solely on one side of an equation and a number solely on the other side, I have two choices. I could get them all on one side and factor them because they would be the difference in this case of squares. Or what I could do is take the square root of both sides. But anytime I take the square root of something that contains a variable, since I don't know what its value is, I have to count for both cases. So what I do is I write a plus or a minus on the outside of the other side. Because again, I don't know what my x value is, that when I take 3 away from it and square it, I get 16. Okay? So what's the square root of the quantity x minus 3 squared? Yeah, when I take the square root of something squared, I get that something, right? Because half of 2 is 1. Then I have plus or minus, and what's the square root of 16? 4. So again, this is solving a quadratic equation using this notion of completing the square. In other words, I need to figure out what x is. I'm trying to figure out the x-intercepts, the roots, the solutions. So is x alone? No. So what do I need to do to get x alone? I'm going to add 3 to both sides. So I get x equals 3 plus or minus 4. So now I have two problems I have to solve. X is either equal to 3 plus 4, or x is equal to 3 minus 4. So what's 3 plus 4? 7. What's 3 minus 4? Negative 1. So my roots to this equation are 7 and negative 1. In other words, my parabola crosses my x-axis at x equals 7 and x equals negative 1. Okay? So there's a lot of things going on in here. Here's what I saw people do, is they took things and they separated them on the test. I think you had a question like this. A lot of people took the minus 18, took it to the other side. And then try to do something like this. The problem was you guys got a little confused. Okay? Square root of 16 is 4. Square root of t squared is t. But here, this isn't 9. It's plus or minus 9. But you're not done because you're not solving for t, you're solving for t, so you have to do one more step. So this one is about time, one of those problems. So you actually have two answers. In positive 9/4 seconds or negative 9/4 seconds. Now you have to deal with reasonableness. Is it reasonable to have negative 9/4 seconds to have something happen? No, that means it happened before it happened. So we throw out the negative answer, but you can't just willy-nilly, because look what happens when you willy-nilly get rid of a negative answer and you don't account for it. You would have excluded one of the answers in our completing the square problem. Okay? That's why you have to understand. If I put in 7, 7 take away 3 is 4. 4 squared is 16. Square root of 16 is 4. Okay? If I put in -1, -1 take away 3 is -4. -4 square root of 16. Okay? Square root of 16 is 4. I don't know which one it is. That's why I need to make sure I always have both of them as possibilities. I do not stop until I have done all the math that I can do. And that's why I didn't stop at 3 plus or minus 4. I need to figure out what my two possibilities are. Okay? Now, where it gets a little bit more complicated is when you have some other issues. So, next one. Oops, sorry. Actually, you know what? Maybe. Because I went through that, you don't know what value x is, so that the number is 4. Or that the number squared is 16. Okay, so you have two possible options there. All right, you know what? I don't want to go more than that. I just want to start here. Let's do one more thing, and that's, what if I just give you a binomial, and your job is to figure out the missing piece? Okay, so let's say you're given this. So I'm going to give you just a few questions off of here, and we'll continue talking about this, on Monday. So let's say we have this. So the question is, find C that creates a perfect square trinomial. So I won't even have you solve all of them. Some of them I'll just have you do this. Okay? So what do we do to figure out what I should replace C with to create a perfect square trinomial? What was our first step? We're going to take our linear coefficient, we're going to divide it by 2, and then what are we going to do to it? We're going to square it. So we get 2 squared, which equals 4. So if I replace C with 4, then that would create a perfect square trinomial. If I asked you to factor that, what would you get? X plus 2. Remember?
Oh yeah, you play the game.
You can play the game, or you can do it this. So factors of 4 that add to give you 4 would be positive 2 and positive 2. Okay? All right, that's it for today. We'll go more in detail on Monday.